Hey guys, Mr. Riz here, and I'm going to help you guys out with the 1.3 guided notes. So this is part 3, and we are going to be dividing out and rationalizing these limits now. So before we could just, factor something out and eliminate. Now what we're going to go through is how can we still find the limit if something doesn't factor out? So that typically happens when we're looking at rational expressions, which are fractions, or even when we have square roots. So what we're going to use is the conjugate to kind of help us out. So if I have this first example here, I have the limit as x approaches 0 of the square root of x plus 1 minus 1 over x. Now I can't just plug in 0 because I'd have a 0 on the denominator, so direct substitution doesn't work. What we have to do is to use our conjugate to help us out. So I'm going to grab my annotation tools here, show you what we're going to do. We're going to multiply the top and bottom by the conjugate. Now, if you forgot, the conjugate is the same expression except for the middle term is switched. So instead of plus in the middle, we put a minus. In this case, since it's minus in the middle, we're going to leave everything else the same. So the square root of x plus 1 and 1, but we're going to put a plus in between. And what we do is on the top and on the bottom to keep everything the same. So the bottom is going to be this really weird expression. It's going to be x times the conjugate. Now the top, what's going to happen is we need to FOIL this. We need to distribute this. Now x times, or radical x plus 1 times radical x plus 1 is just x plus 1. Now what's going to happen in the middle? If I take x plus 1 times it by 1, and then take negative 1 and times it by radical x plus 1. They cancel each other out, so there's not going to be a middle term. The only thing we're going to have left over is the minus 1 times 1, which is minus 1. So after doing that, we do get a simpler expression of just x over x times the conjugate, which is really nice because now our x's can cancel out. And so this expression, we can rewrite it as the limit as x approaches 0 of, well, no longer x on the top, it's now just 1, that's the only thing left over on the top, times the conjugate, radical x plus 1 plus 1. Now this is something we can use direct substitution for, so we're going to plug 0 in for x, and we would get the equation here, let's see, 1 over the square root of 0 plus 1, which would be 1 over square root of, that'd be 1 plus 1, which means we get a limit going towards 1/2. And we could always double check this answer by plugging it into the calculator and finding out the solution, or plugging in 0.000001 or negative 0.00001. Again, really close. We should get an answer that's really close to 1/2. All right, so let's keep going. We'll try some more up the difficulty here, but try it again. And if you guys want to pause the video and try this next one on your own, feel free to do that. So if we want to go ahead and simplify this, we can't use direct substitution. So we're going to multiply the top and bottom by the conjugate, which would be radical x plus 5 plus 3 on the top and on the bottom. All right, so the bottom is going to be a weird expression. It is x minus 4 times the conjugate, radical x plus 5 plus 3. So the top here, we distribute, we get radical x plus 5 times radical x plus 5, which is just a plain old x plus 5. The middle terms are going to cancel each other because we'd have a positive 3 radical x plus 5 and then a negative 3 radical x plus 5. We just got to do negative 3 times positive 3, which is negative 9. So that simplifies to an x minus 4 over x minus 4 times the conjugate. Now this doesn't always happen, but we're starting off easy here. Cancel, cancel, and so really we're going to do the limit as x approaches 4 of 1 over radical x plus 5 plus 3. So that's something we can use direct substitution for. We'll plug in 4. So what's 1 over the square root of 4 plus 5 plus 3? So that is the square root of 9, which is 3, plus 3. 3 plus 3 is 6. So 1 over 6. Okay, so not too bad. Now, this is the technique we will use for square roots. When it comes to fractions, though, we're going to use a different technique. All right, so let's clear this off and try the next one. Now, so for fractions, what we got to look at here, and I will probably find this easier for me to write this as 1 over 3 plus x minus 1 over 3. And I'm leaving plenty of space here for the next step. So fractions, we can't get rid of each other by doing the conjugates. Conjugates only work with radicals because we're multiplying them by themselves. You know, we're basically squaring them kind of to get rid of. Now, if I want to get fractions eliminated, I would have to get common denominators. So the denominator in this one is 3 plus x. The denominator here is 3. If I have two different denominators, if I want to get the same denominator, I'm going to multiply them by the opposite denominator. So I'm going to multiply this 3 plus x by 3 on the top and bottom. And I'm going to have to multiply the 3 by 3 plus x on the top and bottom. So totally ignoring this x that's on the bottom here right now, I would get a 3 over 3 times 3 plus x. Now I could distribute that, but you'll see it won't matter later on. Then minus 3 plus x over 3 times 3 plus x. Okay, so the first step is I multiply to get common denominators. Now that I have common denominators, totally ignoring the x again, I could combine those into one fraction. And let's see, 3 over 3 plus x. I could simplify this. I could combine 3 minus 3 plus x. So it would be 3 minus 3 goes away. And I'd still just have the minus x. So I'd have a negative x left over. Now what we're going to do here is, now that we have this simplified, this top expression simplified to one fraction like this, we can actually look at this and remember that dividing by x is the same thing as taking the top fraction and timesing it by 1 over x. Now that's super nice because x's will cancel each other out. And we are left with the expression, the limit as x approaches 0, of negative 1 over 3 times 3 plus x, which is something we can use direct substitution for. So what's negative 1 over 3 times 3 plus 0? Let's see, that'd be negative 1 over 3 times 3, which is 9. Negative 1, 9. So fractions we'll probably do a little bit more practice on. So I think it'd be good right now to go through, maybe look at the CYU problems, do one of them that have a fraction, and then look at the other types that we'll be looking at. Okay, clear all my drawings here. Let's go to a CYU problem. Make sure I'm sharing this. All right, so here we go. First problem, we got the conjugate. Should be all right with that one. Same thing, conjugate here. You know, things are going to cancel out. So, okay, we got a fraction problem for number 3. Try to zoom in a little bit so we can see better. Okay, so if I wanted to go ahead and combine these, I would have to multiply this one by 4 over 4, multiply this by an x plus 4 over x plus 4. So still just kind of leaving the x alone on the bottom here, I would have a 4 over 4 times x plus 4 minus x plus 4 over 4 times x plus 4. So we've got our conjugates here, or not conjugates, got our common denominators, and now we can combine those. So what would, leaving the denominator alone, all right, what's 4 minus x plus 4? Well, that'd be 4. We'd have a negative x, and the 4 minus 4 would go away, so it's just a negative x. So just like last problem that we did, I can change this expression. So instead of dividing everything by x, I can multiply it all by 1 over x, which makes this x's go away, and we're left with the limit as we go towards negative 1 over 4 times x plus 4. So now we're going to go towards 0 here, and it's going to be negative 1 over 4 times 0 plus 4 That'd be -1 over 4 times 4, -1/16. I think you can type it in as a decimal or as the fraction. Okay, so next what I want to do is kind of look at the last problems here, these delta x problems, make sure we can handle those. All right, that one is multiple choice, so I think you guys can, if you have trouble, just guess them. But this one here, the limit as delta x goes through 0. So this will make more sense when we really get into the evaluating derivatives, but we're going to use this just to practice here. So delta x is just like any other variable. It's like a y, it's like a z, it's like a h or a k. All right, it just is the delta x. So neither delta or x, they're combined together. They're not multiplied together, it's just a symbol. So if I was going to square this here, what I probably would want to do is distribute this, because I can't just plug in 0 for delta x. I got to be a 0 on the bottom. So let's distribute this. So if I was going to do x plus delta x times itself. Okay, so let's see. X times x is x squared. X times delta x is x delta x. Like x times y is xy. X times delta x is x delta x. All right, then delta x times x is another x delta x. And delta x times delta x is delta x squared. All right, then minus x squared all over delta x. Oh, okay, so we've squared this term here. Let's see what happens. Well, our x squareds cancel each other out. And we're left with, let's see, we'd have 2x delta x and another delta x squared, and this would be all over delta x still. Now, we still didn't get this out, but if we look here, this top term, both of those have a delta x, so we could factor out a delta x. So it'd be a 2x plus delta x, which is nice now because we'd have this factored out. It could cancel one from the top and one from the bottom. And so our limit expression is as delta x approaches 0 of 2x delta x. Now that is something we could use direct substitution for. We can plug in, we don't have to worry about because there's no denominator, 0 right in for delta x, so we get 2x plus 0, which is just strictly 2x, and so that's what you'll type in here. It'll be 2x. All right, so hopefully this helped you out with part 3. We'll finish this section up tomorrow with part 4, but if you guys have any questions, just ask. If not, I will see you guys later. Have a good one.